All right, guys, we're now looking at 6A.2. Our master learning objective is I can determine the scale factor and center of dilation by comparing the pre-image and the image. Okay. So what is a dilation? A dilation is a try that again. So a dilation is a transformation. Sorry, this is being annoying. Let's see if I do this, if it will stop. Okay. A dilation is a transformation that changes the size of a figure without changing the shape. Okay. So if you look at this picture on the right, so it changes the size of a figure, but it doesn't change the shape. If we look at this picture, right, if I think of ABC as my original first triangle, then JKL has gotten bigger. If you look, if these triangles are exactly the same shape, and by that we mean, and we'll talk more about that like in our next unit as well, what exactly we mean, but I could literally roll this up, right, zoom in, and it would look exactly like this. Okay, so like when you zoom in on something, that's a dilation. You're not changing what it looks like, you're just making it bigger. You can also make it smaller. So changing the size can go either way. Then our scale factor is how big or small we are making the new shape. Okay. Our scale factor, we use the letter K. We say K equals, and the best way to do it is new over old. K equals no. Okay, so it's the length of the new shape or the size of the new shape divided by the size of the old shape. Okay, so it's a proportion. And we divide it. And we'll see some examples of that, what that actually is. So an enlargement means the shape gets bigger. Makes sense. Okay, so an enlargement is the shape gets bigger. So it started here and it went to this green shape. Okay, and this is important. That's not right. I like copy and pasted this picture from a textbook and it's wrong. Let's cross that out. When it gets bigger, your K, that scale factor, is going to be greater than 1. For example, if my K is 2, it means it's doubling in size. If my K is 3, it means it's tripling in size. Right? This one's right. So K is bigger than 1. Remember, the alligator eats the bigger number, so the alligator is eating the K. In a reduction, the shape gets smaller. So 0 is less than K is less than 1. Okay, so our scale factor is never negative. That's all this means. But it's less than 1. So it's half, a third, 4/5, anything that's less than 1. Okay? And again, like half would mean it's half the shape. So again, here we're starting at this blue image, and we're going to this green image. So the picture shrank. So it's a reduction. So let's look at some examples. Determine the scale factor from figure A to figure B. I'm going to call this figure A and this figure B. Okay? Whatever you start with, that's your old. Old comes first. So this is our old, and this is our new. So remember, so is this a dilation or an enlargement? As I'm going from A to B, well, B is definitely bigger. So this is an enlargement. And then finding my scale factor, remember your scale factor, K, is your new over your old. And then I have to pick a side. It doesn't matter which side I start with as long as I choose the corresponding side. So I have to pick a side in my new figure. Again, I don't care which one. Let's choose the 16. So then in my old figure, I have to be careful. I was choosing this side in my new figure, so I have to choose the same side in my old figure. So I have to do that 8. And then 16 divided by 8 is 2. So the scale factor of this dilation is 2. Okay, let's go ahead and look at the next page. Same type of example. And we'll call this A and this B. So old. Ooh. Remember, our first one is our oldest one. Our second one is our newest one. And again, I have to decide, is the second one bigger or smaller? Well, it definitely looks bigger to me. So, again, so this is another enlargement. Then doing our scale factor. New over old. So again, I'm going to start with my new, and I can choose any side, but I do want to choose intelligently, right? If I choose this side 24, it would match with this side here. I don't know what that side is. But if I choose this 48, it matches with this side 40. I know what that is. So I have to choose a side that I know. Okay. So I'm going to choose 48 over 40. Which does reduce, so we want to make sure we're reducing our fractions to 6/5. So 6 over 5. All right, looking at our next one, determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor of the dilation. Okay, so now we have these graphs, and it doesn't tell us the lengths of the sides. So in order to do scale factors with graphs, we have to just use the points. So here, same thing. I'm first going to determine if it's an enlargement or a reduction. So A, this blue figure is my old. To B, this green figure is my new. Well, my new is much smaller, right? So this is going to be a reduction. So then I do my scale factor, which is new over old. I just pick any point. So let's pick this one. That's 1, and then it goes about halfway through. So I'm going to call it 1.5. And then it goes up 1. Then I have to pick the corresponding point on my old. Let's make old blue, because then it matches the colors. So here it's this corner, so I have to pick this corner on my old as well. They have to be a corner. It can't just be any random middle point. You don't know how those line up. Has to be a corner. Here, this is 1, 2, 3, 2. Now we're going to divide. You could divide your x's or your y's, whichever is easier. In this case, I'm going to divide my y's because they're both whole numbers, and that seems easier to me. Instead of dividing 1.5 by 3, just 1 over 2 is just 1/2. Done. All right? So this green shape is half the size of my blue shape. And that's it. Okay. Otherwise, okay, so let's look at example 4. So same idea. We want to first decide if it is a enlargement or a reduction. So I'm going from A to B. That means A is my old. Okay. And B is my new. Well, if I look here, if I'm going from A to B, B is definitely bigger. Right, so we're always deciding if our new one is bigger or smaller. It's bigger, so it's an enlargement. So I'd expect to get something greater than 1. So K equals new over old. Well, my new is my B, so I'm going to choose any point on B. And I'm going to choose this point here. Doesn't matter. Okay? 1, 2, 3, 4. 1, 2, 3, 4. So that's 4, 4. Over. I have to choose now the corresponding point on A. If I go this corner on B, then the same corner in my figure A is this corner. 2, 3. 1, 2, 3. Then it does not matter if you choose your x's or your y's. Again, whichever one's easier. If I look at these, they're the same. It's just 4 over 3. Okay, so again, whichever one's easier. All right. That looks good. Looking at our next 5. Again, A is our new, or sorry, A is our old. B is our new. Again, if I look at my B compared to my A, B is definitely bigger. So this is an enlargement. My scale factor equals new over old. I'm going to pick a point on my new. Again, sure, this point we have 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. It's nice when these work out so nicely. And then I have to pick the same point on my A, which is 1, 2, 3, 4. 1, 2, 3, 4. Again, dividing those, that's 5/4. Again, it doesn't matter. I could also choose these. It's still 5/4. Right? All right, last problem. A is my old one. B is my new one. I like this problem because, right, we usually read like left to right, so you have to be very careful with your figures that you're just paying attention to what one's labeled A or B or however it tells you. Okay? So still finding our scale factor, K Oh, sorry. And our new is definitely smaller. So this is a reduction. Alright, it got smaller. So K equals new over old. I'm going to choose a point in my new. I'll choose this point here. That's 1, 1. And then I'm going to choose a point in my old. Same point, which is 3, 3. I'm going to divide these, and I get 1/3. And that is it. Go ahead and work on your activity.